And welcome to the Daily Space Weather Show, the show where we help our viewers think things through, occasionally to their logical conclusion. If you'd like some discernment, folks, learn to think things through to their logical conclusion. It will help you out, I suspect. That's the past 24 hours on the closest star. So we do have some CMEs to cover once again today, coronal mass ejections. Also some dud impacts that have created a waning warning for space weather. It's been weak. Let's add some more data here. There's 131 in addition to the 171. And let's take a brief look at that there star a little bit more closely, shall we? There's the equatorial zoom. The most active region has been in the lower right, the southwestern limb. And there was another minor proton event triggered by one of the outbursts from that active region down there. We'll show it later in the video. And before we get to any of that, let's take a brief look at, check it out, it's Sangay volcano. A very foreboding looking image there. And these are the rest of the volcanoes that are erupting. Sakurajima, Ibu, Semaru, also Merapi, Dacono. Don't forget Popocatépetl, Santiaguido, Fuego, Sangay, there's Sangay. 23,000-foot ash plume there over Ecuador from Sangay. Revenador, Sabancaya also erupting, 23,000-foot ash plume there. And Villarrica. Please do not pole vault the caldera. And pardon my appearance, the green screen might be a little funky looking. The blaze orange has a tendency to mess with the green screen. I don't know why. Anyway, looking at seismic activity, and I believe there should be an ongoing earthquake watch for the North American / Pacific plate boundary, but that's just me. Let's talk about quakes of a 5 or greater magnitude for the past 24 hours. It's been a pretty active 24 hours. As we said yesterday, there was a drought of 6.5 magnitude earthquakes and bigger. So a little bit of an earthquake drought here continuing, although we did have some 6+ magnitude events. So this 6.0 at Chile was one of them. That was early this morning at 1:31 Universal Time. South Sandwich Island has had a 5.7 and a 5.2 aftershock. Japan had a 5.2. Philippines had a 5.0. That was at only 7:21, so a bit of a busy morning there. And then Micronesia had a 6.0. That was at 11:40 this morning. Vanuatu had a 5.8 at 18:58 this evening, and that's where the quakes end. Here's some more imagery for you, by the way. There's the 335 angstroms wavelength from SDO. We don't always show that one. That one's good at showing active regions, mainly just active regions. It is also okay at showing filaments and coronal holes. 335 angstroms, folks, one of the many species of ionized iron. And its extreme ultraviolet emissions. The sun's atmosphere, it's a rich chemical soup. And next we'll take a look at some stats like the 10.7 centimeter radial flux and so forth. The radial flux now at 184 solar flux units. The 10.7 centimeter radial flux, the most proportional data set that we have to sunspot number. And allow me to make an adjustment here, folks. I'm just going to make a little adjustment. Whoa, what happened? Oh, geez, oh whiz. All right, again, I apologize for the green screen settings. I think that's a little bit better. So, yeah, radial flux now at 184. There's the 1 year graph. The black line is a radial flux. The red line is a sunspot number. The blue line is the AP index. Space Weather Enthusiast dashboard here. Still forecasting a little bit of geomagnetic unrest tonight, but the likelihood of space weather is waning at this point, folks. So a couple dud impacts there, several dud impacts. I mean, barely even a blip on the solar wind telemetry, which we will show you in just a moment. So here's Earth's magnetic moment from space for the past 4 hours. It's our geospace magnetosphere movie, and things are quite calm for space weather. So surprisingly, no geomagnetic storm conditions have shown up despite multiple CME impacts forecasted by both us and NOAA. So that's an oddity. Although this time NASA was correct. So that's interesting. It makes me want to reach out to NASA. Anyway, there's the past 4 hours of Earth's magnetic moment from the ground level, our ground magnetic perturbations map, and we'll move on to the KP index, which is at 0.67 actually. 0.67 is the average of global geomagnetism for the KP index. And we never even got to geomagnetic unrest. As you can see, KP 3.67 was as high as we got. So there's the data from ACE. Little tiny impact there happening, but barely even anything to register. Let's skip ahead to the Discover. Only a little bit of a magnetic field fluctuation there, so that CME must have brushed past Discover, basically missing it entirely. Anyway, the Discover is returning about 10.5 protons per cubic centimeter for the solar wind density. Solar wind velocity here under 500 kilometers per second at 487. 487 is the solar wind velocity at Discover. Ghost magnetometers here did feature some sawtooth spiky readings there in the past couple of days, but no real space weather. But some decent variations happening there in the ghost magnetometers. So that's something. That's space. I mean, the GOES are at like 23,500 miles of altitude, way out there in the outer portion of the outer Van Allen belt. So they're at like twice the altitude of a GPS satellite, the GOES 16 and GOES 18. Next, the top view ecliptic plane field plot. And by the way, thanks for tuning in to the Smash News Network least busted name in news. That's the past 4 days, and Earth is still in a North Pole-oriented magnetic sector. You can expect to be there tomorrow, too, assuming nothing rapidly changes in the magnetic environment. There's our line-of-sight field plot, and a lot of data there squeezed into one series of pixels. So, polar fields are in red and green for south and north. The solar B field is in blue, and the photosphere magnetism is in grayscale. Great snapshot of the last 4 days of what the sun has been up to. Next, our line-of-sight coronal hole plot. And we do have South Pole-oriented coronal holes there, evaporating and then reforming in the northeast. So that is an area to watch. The area up there in the northeast is certainly something to keep an eye on. And when I say eye on, pardon the pun. So check it out. Here is the SDO 211 angstroms wavelength. And this area right up here is another miniature terminator event. So we've got varying polarity in this area. That is an area where we are likely to see a breakout of one magnetic field or the other, and the likelihood of sunspots to form. So there's a forecast for you. Forecasting sunspots before they appear. Hope you enjoyed that. And let's continue on to sunspots. Since we're on the subject, I mean, we might as well talk about sunspots, right? So yeah. Sunspot number here back over 150, or just almost to 150. 148, 149 is the sunspot number. And there's our synoptic map, a brief look at that by WC. You see the likelihood of an X-class flare is kind of high, and it's mainly down here in the southwestern limb. So WC and I agree on this one. That is the most likely place to see a large solar flare. These are the flare. This is the flare probability for C-class, M-class, and X-class flare. I'm sorry, it's not. This is C-class, M-class, X-class, and proton event likelihood, which is what's up here. It's just an on the sunspot basis when you see it on here. So, yes, I 100% agree. that the southwestern limb is the most likely place for a large solar flare. Moving right along to our flare probability monitor and scoreboard, and you'll see that indeed agrees as well. Sunspot 3576 remains the T-mass. It's back with its title as the T-mass, the most active sunspot. Let's take a look at sunspots from SDO. There are the past 24 hours. And that's what approximately 150 sunspots look like. Now, we will have an uptick in sunspot number by tomorrow's Daily Space Weather video because of new active regions rising in the northeast. So, expecting a minor uptick in sunspot number. Some activity happening down there in the southeast as well. Look at some new spots forming down here. So a mild to moderate uptick in the sunspot number between today and tomorrow. Here's the SDO magnetogram as well. And besides the eastern portion, most of those other sunspots remaining largely stable. Continuing right along to our radio blackouts. Yeah, we've got some radio blackouts going on here, mainly in the south polar region. They are subsiding as the proton flux returns back to baseline levels. You can see that slowly becoming a radio brownout around the southern pole. So there's the ghost proton flux. Like I said, it is subsiding here. We did have a minor proton event that kicked off as a result of one of the flares today, or associated with one of the flares today. It was probably this one. Might have been this one. But a couple M-class events happened there. Otherwise, the X-ray flux here, pretty quiet. Background X-ray flux is something like a C1.8. So a little bit of a downtick in the X-ray flux here, and some minor flaring happening in the southwestern limb as we create the video. And I don't know why that's dim. Let's skip it and look at sunspot 3576. So there's a great 24-hour video. That's 94 plus 131 angstroms. More species of ionized iron and their extremely hot ultraviolet emissions. And there's the extreme close-up of our T-mass, sunspot 3576. One of the most exciting sunspots of the solar cycle so far. And by tomorrow, at the end of the day, it will be out of view. So hopefully sunspot 3576 will make it all the way around for another showing. It has been a great sunspot for space weather enthusiasts like you. Anyway, continuing right along to our star chart. And that's what's going on overhead Lehigh Valley, Pennsylvania. Check out skyandtelescope.org if you want to make your own star chart. Just put in your location. If you're seeing the early dusk sky, you might see the moon and Jupiter up there high on the ecliptic in your early evening skies. Next, the solar system forecast. There's where things are today. We'll advance this 1 week. There's where things will be in 1 week as Earth is on a lonely side of the solar system. No other planets over here where Earth is. Next, our astronomy photo of the day. And this one is quite spectacular, folks. Some hot, energetic, and exciting stars. Especially in the Cone and Foxfur Nebula, but also the Rosette Nebula is quite picturesque. Let's take a look at it a little bit more closely. First, the Rosette Nebula, which we actually showed just a few days ago on the channel. And I'm going to do a slow scroll across that. Shout out to Olivier Bernard and Philippe Bernard for this fantastic imagery. Let's take a look at the Rosette Nebula a little bit more closely. Am I missing it? There it is. So there's the Rosette Nebula. Looks a little bit like a rose. It's almost like a tunnel. As these stars in here, these bright, hot, blue, giant stars, they're blasting out stellar winds, which are slowly excavating this area in the center. And of course, you can see a bunch of filaments in those areas as well, as that matter starts to sort of coalesce in some ways. So the light and stellar winds from those massive blue stars pushing out on that nebula, as well as illuminating it from the inside, which is why it looks the way it does. The blue is probably oxygen, and the red and orange are probably hydrogen. And then that other nebula, which has some really beefy looking stars in it. Where is it? Where'd it go? There we are. Yeah, so check out that nebula. That nebula is... I like this one even better. I mean, it's got evidence of some really strong stellar activity in there, because you can sort of see... I think it's probably this star right here. See that star right there? That might be the center of that nebula, but it looks like we've got massive stellar jets that are kind of blasting out in these directions. So those may be the polar jets of that star. Not too sure about that. There could be multiple things going on at the same time there, but that is an extremely interesting area indeed. And of course you can see an area down here that looks almost like a pulsar wind nebula. So very fantastic imagery here today on the apod.nasa.gov, the astronomy photo of the day. Anyway, we're going to move on to coronal mass ejections next. So first of all, the LASCO C2 and C3. Let's get a little bit closer. There we go. So now the C2 on the left is a little bit ahead of the C3. So what do we have? There's a significant event there out of the southern hemisphere. Starts appearing around 4 o'clock. That one looks like it has earthly directed components, folks. Let's take a little closer look, but first stereo A. Here we've got the stereo A raw coronagraph on the left and the difference imagery on the right. It's just pixels subtracted from previous pixels. So yeah, around 4 o'clock. Major CME popping off there. And I think that one is earthly directed. So great CME there. It's got a partial halo already. Let's take a look at some even better views here from HelioViewer. So not sure on that one. Let's take an even closer look. There we go. And what we're looking for are filaments. So let's see if we can figure out where that CME originated. And I'm not so sure that's on the Earth side. So I do see an event up here that looks like it could be a CME, but I don't really see it popping off at the right time. My best guess is that that CME is on the far side. So sometimes it's very deceptive, and this is one of those times. I think that is a far side CME. So let us know in the comments if you agree or disagree or whatever. And let's move on to filaments. So filaments are super important. They sometimes become coronal mass ejections, so we cover those also in the world's most comprehensive daily space weather content. So there are filaments and prominences from the Cerro Tololo, Chile, ground-based solar observatory, part of the National Solar Observatory. And there is the colored view and some very dense filaments there. Yeah, I don't really see any filaments blasting off today from the Earth side, so I suspect that is on the far side. What say you? Let us know in the comments. Anyway, let's get the bonus features here. Again, a little bit of flaring activity happening down here in the southwest. Here come bonus features. Satellite charging hazards. We ain't got none. It's smooth sailing for satellites. No surface or internal charging hazards for satellites at the moment. Goes electron flux is still at low levels. And let's see what the 1 year chart looks like. There you go. There's the 1 year chart. It still is kind of an electron shortage, really. I mean, that's those are measured at the F-flare of the ionosphere, by the way, folks. The greater than 2 mega electron volt electron fluence. So here's NOAA's forecast model, and it looks like they may have watched our video yesterday and changed it, but but there you go. Expecting fairly low levels, and that looks like that next green box is going to be right. So, cheers. Next, the layer where it's measured. You got to have the F layer. I mean, you're effed without the F layer. So here it is in vibrational frequency, the F layer of the ionosphere. That's about 300 kilometers of altitude, folks. The vibrational frequency is measured in megahertz. It's the ionosonde from Australian Government Bureau Meteorology. So things not nearly as low frequency as we expected, since the CME impacts were extremely weak, much weaker than expected. So hey, what can I say? Sometimes you eat the bear, and sometimes the bear eats you. There's the anomalygram, anomaly in megahertz from a 30-day median. And yeah, that's what's going on there. Not a lot of space weather. And happy Valentine's Day, by the way. If you want to name filaments after living people, do it over on Twitter. Yeah, x.com/smashomash is where you can follow us over there. Follow the hashtag #NameThatFilament. And if you'd like to see content nobody else gets to see, definitely join us over there. Otherwise, you're not seeing us on social media. I don't know. Yeah. Cheers. Anyway, there's our Global Ionosphere Nowcast, or WHAM. Wake me up before you go, showing the total electron content on the left. Wake me up before you go, and use the high-frequency radio emissions for the right. Wake me up before you go. It's time to close out the space weather section and move on to meteorology. And get some forecasts tonight. All right, so here are the latest images, the magnetogram, and this new sunspot that just rose up here is looking like it's alpha class. There's a new one there as well. There's also one down there. So it looks like 3 new named sunspot groups tomorrow. There's a full disk rockback. Again, the most likely place for a large flare is sunspot 3576. And let's move on to our meteorology segment, where I say, dear God, oh my God, look at the Earth. It looks like it's being heated up on the one side and it's losing all this heat on the other side. Dear God, what is going on? That's the UV index, folks. That's the UV index. And you're probably saying, what's going on in these areas? Any guesses as to what's going on in those areas where the UV index isn't that high, even though it's the sunny side of the planet? Any ideas? Anybody want to guess? Anybody? Could it be because there are clouds there? Oh my God, look at that, there are clouds there. I must be a meteorologist, as I understand basic physics before I put out these videos for you. By the way, a high school level of physics understanding is helpful to view our channel. Like, we try to break stuff down to high school physics level. So, anyway, that's the illuminated side of the planet. Again, if you want to look at the UV index yourself, it's nullschool.net's wind and sky map, which is splentacularly awesome. You should totally check it out. And let's move on to our regularly scheduled meteorology. So there are the surface winds of the east. These are the jet streams. Jet streams of the central world shown here. Surface winds of the central world. Here. Surface winds of the west. Here. And let's don't forget the jet streams. Next, clouds and fog. Yeah, clouds and fog. It's shortwave radiation from a satellite over North America and South America, the Americas. And let's take a look at the center part of the country as there's some snow moving into the Great Lakes region. So there you go. Looking pretty chilly up there in Canada. Multiple low pressures. Next, our snow forecast. So there are the next 3 days according to the Euro model. And there are the next 3 days of new snow on the GFS model. So let's Let's rock it back, shall we? GFS model, new snow for the next 3 days. Euro model. GFS model. Euro model. Moving on to our weather.gov map. There are the winter storm warnings and watches. We showed you the key. There are a lot of counties lit up. If you've got a weather warning, head to weather.gov. Next, lightning. That's what's been going on for the past 10 hours. And here's a real-time lightning map, courtesy of lightningmaps.org. Looks very active here. 250 to 300 strikes per minute there. Mainly because of, I guess, the eastern Mediterranean once again. So, I don't know. Maybe there's weather modification. Maybe Eric Schmidt's modifying the weather from his home at Cyprus. Maybe that's what's going on. Ever think of that, folks? Maybe that's what's happening. Anyway, quite a bit of lightning strikes there. Mainly around the Middle East. Am I allowed to say Middle East yet on YouTube? Middle East, Middle East. Next, Doppler radar, which shows vertical motion in the air column from ground-based Doppler radar systems. We'll focus on the lower 48 and close this mother out. Once again, happy Valentine's Day, folks. There is clouds and fog as well. And let's don't forget the water vapor map. When your Doppler's unclear, use the water vapor. More on that in just a minute. First, a recap. Doppler radar for the lower 48. Clouds and fog depicted by the shortwave radiation satellite, part of the NASA GOES interactive weather satellite suite. And last but not least, water vapor. Important thing to remember about this map, folks. See this dry air right here? This dry air is more massive than the neighboring air. So that's a relative high compared to these areas here, which are relative lows. And anyway, it's time to close this thing out. So thanks for tuning into the Smash News Network, least busted name of news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. While I go back to the bunker again, I climb on down here, and then tomorrow I'll return again.